So we have talked previously, this review, we talked about three classes of wireless networks defined for Wi-Fi 6E. We talked about VLP, very low power, 14 dBm. We talked about LPI, low power indoor, which is up to 30 dBm if you can get a 320 megahertz band channel width. And we talked about standard power, or SP class. And the SP class allows up to 36 dBm total transmit power, EIRP. So that's something we're very familiar with, but requires the access points and that network to be under control of an AFC system, an automatic frequency control system. So it's an external management entity that tells your SP network what frequencies it can use and how much power it can transmit. So there's that third party thing. So because that third party AFC system is involved there, many people are looking at LPI to be the standard technology. Let's drill into that. Actually, you know what? I got to ask you, because I'm kind of wondering this myself as I was preparing for this webcast. I'm looking at these classes, VLP 14 dBm max, and it's not really germane to our conversation, but I got to ask you, what the heck are they thinking? What good is What good is 14 dBm? I can't figure out the use case.
That's a good question, but I mean, scratching my head, thinking like an engineer and having a really awesome sound system in my house, I start thinking, if I had that low power thing with that 6 gigahertz, my DVD player could talk to my TV and I wouldn't need that HDMI cable. And then my remote speakers, I wouldn't have to get up in my attic and run cables over from my receiver over to the speaker sets and everything like that. So, I mean, this allows, the average day user just to kind of set some things up and not necessarily have to have some of those specialized skills of being able to saw on the wall and, put in bring the wires down and all this other stuff. So, I mean, it's just if I got power to it, which, in this day and age, battery works just fine. And one of the capabilities of the Wi-Fi 6 itself is only waking up when I need to be spoken to. So it's going to have that reduced power capability. I mean, it really looks, to be utilized in, the IoT market. I mean, that's what I'm really going to kind of break that down to.
Interesting. You brought up a couple of good things to think about. I'll give some thought to those. But interesting about what your comment there, Mitch. You're talking again about devices and applications driving the network topology. And that's actually been true for many years. We just look back the last 10 years. Let's just go back 10 years. We can go back 20, but let's look at the past 10 years. So this is 2021. Go back 10 years ago, 2011, we were 6 months at this point. Well, actually go back 11 years. So by the middle of 2010, May 2010, Apple introduced the iPad. And quite frankly, turned the world on its head. They kind of expected Apple would do it. Nobody expected it would take off as quickly as it did, which became super popular. Tablets became all the rage. Tablets everywhere really changed the density. Not only tablets, the timing was really right because smartphones by 2010 were taking off rapidly. The growth rate of cell phone adoption, smartphone adoption was just growing every year, leaps and bounds. So some markets really changed dramatically. For example, hospitality. I was been involved in that for a lot of years. Between 2010 and 2012, just in about an 18 to 24 month period of time, the networks increased over 2 times density and over 2x the number of devices, active devices in an average hotel over a period of about 18 months. And then the next 18 months, they doubled again. So there was this dramatic increase in the numbers of devices that are being used. And that really did change the way networks were designed. So I'll use hospitality as an example again, and very similar to other types of MDU applications like healthcare or long-term care facilities. When the client density increases that much, and they're starting to do more with it, like streaming multimedia, streaming media, watching movies and things, what happens is your AP and clients, the AP cell sizes have to shrink. They have to get smaller. And that actually happened in hospitality. You go back 2010, we were still deploying networks in the hallway, on the ceiling of the hallway, roughly one for every 8 rooms. But that very, very quickly started to fail as smartphones and tablets with their smaller transmit power really took over the market in 2010, 2011, 2012. So by 2012, that 1 to 8 ratio was down to 1 to 5. Another year, it was down to 1 to 4. And then all of a sudden, the wall plate APs, people realized, wait a minute, we should be doing this with a wall plate AP, which actually were available in 2009, 2008, but they weren't that popular until the density drove the requirement. So by 2014, 15, 16, you're starting to see wall plate APs dominant in these MDU type applications, starting out with one wall plate for every 3 rooms. Then it was 1 to 2. By 2018, there's one wall plate access point in every single room. Again, driven by the client devices and the applications in order to support the streaming multimedia, in order to support the low power smartphones and tablets and their lower transmit powers and their battery operation, and to be able to maximize their batteries, really drove that size of those wireless cells to be very, very small. So that has been something that we've all had to deal with. How about you? What do you? Is there any markets that you think of where the applications and the client devices have driven the technology changes and the network design?
Yeah, I mean, you brought up the medical field, right? I mean, a lot of their stuff, they do RFD tagging to know where it's at. They tag their people to know where their people are for safety reasons. And I mean, a lot of that stuff is coming across Wi-Fi devices that are sharing that Bluetooth capability is for knowing where location where people are. And we'll even take a recent example. Whenever COVID came out, Wi-Fi was being utilized for that to be able to do contact tracing. So, I mean, those cell size are really important because, if I get a wide cell size, well, I'm not going to really be able to track that device as accurately as if I can make that cell size start being smaller, right? So, I mean, just for the pure fact of being able to do contact tracing, knowing where my equipment's at through RFD tagging. Education does kind of the same thing, right? Where now they're putting a bunch of tablets in the hands of students instead of spending the money on books. And so there's there's really about an AP per classroom now. I
Yeah.
mean, it was kind of the same thing as the hotels and everything else where, you kind of put an AP out in the hall, and you're kind of expecting some coverage, or maybe every other room, kind of start changing every other room. And, then, we've had also kinds of designs for multi floored places where sometimes you skipped a whole floor because of the way that you did your density for your channel reuse. But you're right. Now it's like, okay, we're down to what almost you could say is a picocell in the sense of what we do to deliver to our clients.
Good. Yeah, good. All driven by the device types and the applications.